let's continue. So we move on to the next speaker, and that's Jerry Cow, who is a product manager at Trina, and he will talk about their N-type solar products, innovations with Vertex N modules. Jerry, the floor is yours.
Yeah, greetings, guys. Hi, Michael. Please allow me 1 minute to share the screen. Can you see my slides?
Not yet. Now, yes.
Okay, fine. So here we go.
Please move to. Yep.
Okay, so it's okay now for you, the full screen one?
Yeah.
Okay, sure. Okay, thanks, guys. Good morning, ladies and gentlemen. This is Jerry from Trinasolar. Today, it is my great honor to introduce you the white paper of our Vertex N products family. Of course, it's a module one, and it will further lead the way to the lower LCOE. As WMO mentioned before, the last 8 years have been the warmest on record, making every heat wave more intense and life-threatening, especially for vulnerable populations, which highlights the urgency to establish the new energy system in which the PV is playing the leading role. And for our industry, there is a permanent pursuit for the lower LCOE. According to the researches done by Trinasolar, there are 4 keys from the module side to unlock the low LCOE. They are the high power, the high efficiency, the high capacity of power generation, and the high reliability, which perfectly describes the characteristics of the Vertex N product family. For today's agenda, we will firstly go through the key technologies of Trinasolar TOPCon products. After that, there will be the in-depth introduction to the 210 plus N type, making the advanced more advanced, which will consist of the 4 keys to the lower LCOE and how Vertex N products achieve it. Last but not least, I will share some latest progress of the industrialization of Vertex N products. In the last 25 years, Trinasolar has always been one of the most innovative companies, which is not only limited to the 25 times of world records breakings. Besides, Trinasolar is devoted to introduce the latest technology to massive production, which ultimately benefits our customers by creating more value. For example, the dual glass design, the multi-busbar technology, and of course, the advanced 210 technology platform. Today, we are going to introduce the TOPCon technology, which increase the efficiency and will create more value. As early as the year of 2015, Trinasolar has started the initial technology development on TOPCon, and after several times of world records breaking, in the March of 2022, we achieved a site efficiency of 25.5% based on the 210 large size wafer, reflecting the leading role in this research area. Based on such an advanced technology, we successfully participated in the Top Runner projects launched by the Chinese government and shipped 500 megawatts N-type modules to the projects based in Tongchuan and Changzhi, which was successfully on grid in the year of 2019. And in the next year, another 135 megawatts of N-type products were delivered to Qinghai province, showing the inspiring efforts that Trinasolar has made to the industrialization of the TOPCon technology. So after the review of the history of development, there are more details on N-type TOPCon technology. First of all, we adopt the basic TOPCon passive contact structure, which creates the selective transfer mechanism for the carriers, actually the electrons, and therefore increase the open circuit of the cell so as its efficiency. On top of that, Trinasolar has achieved 3 key technical breakthroughs, which contribute more to the higher cell efficiency. The first one is the PECVD poly technology, which is able to create the single poly layer to reduce the optical loss on the backside. Besides, the application of selective emitter technology can lower the contact resistance and increase the open circuit voltage. At the same time, the laser's potential damage on the cell is carefully considered and controlled, which maximizes its contribution to the cell efficiency. Last but not least, we adopt the high-efficiency hydrogen passivation technology, which makes the defects fewer so that the minority carrier can have a longer life. Except for the N-type TOPCon technology, the Vertex N module product family is adopting more advanced technologies to make the excellence. The first is the application of the 210 and the 210R large-sized wafers, which significantly reduce the own cost of our customers. Besides, we apply the multi-busbar technology, which improves the current collection and therefore increase the power output of the module. Thirdly, the non-destructive cutting technology can maintain the excellent mechanical performance of the cells after cutting so that to lower the micro-crack risk. Last but not least, the high-density encapsulation technology is able to increase the module efficiency by 0.2 to 0.3%. To sum up, the Vertex N product is based on both the 210 innovative platform and the N-type TOPCon technology, making the advanced more advanced. Then here are the 4 keys to the lower LCOE. Generally speaking, the LCOE is impacted by both the total cost and the total power generation of a PV station during its life cycle, upon which the key features of Vertex N product can contribute a lot to the lowering of it. First of all, the Vertex N product is having a high power and efficiency. Adding its low voltage design, it can increase the string power for the CNI and the utility application so that to contribute to the saving on the BOS. Besides, the Vertex N product is able to generate more electricity compared with the PERC ones during the product life cycle, which are mainly based on the 3 key advantages: the lower temperature coefficient, the lower power degradation, and the higher bifaciality. Last but not least, the high reliability is the foundation of all those excellent performance. And for the Vertex N product, it has been well proved by both the tests and the empirical studies. Then here comes this family of high power and efficiency. Take the small sized NEG9R.28 as an example. It has the maximum power up to 440 watts within an area less than 2 square meters, leading the power and the efficiency trend in this segment. Besides, for the mid-sized NEG19RC.20, it is usually 25 watts higher compared with the ordinary N types, so that in a utility project, it is able to save the BOS by 0.55 cents US dollars per watt. And this power advantage is increased to 70 watts higher for the NEG21C.20, the largest one. And for a Brazil-based project, it can even save the capex up to 1.44 cents US dollars per watt, creating more value for the customers. Then let's look at how the Vertex N product can contribute to the saving on system. As we can see on the table, the lower open circuit voltage can allow for the Vertex N product family can allow more modules connected in a string for the CNI and the utility application, adding its significant characteristic of higher power. The string power of the 210R 595 watts is increased by 13% compared with the ordinary N-type modules, and that advantage is increased to 30% for the 210 685 watts module. Therefore, for the customers, choosing Vertex N products means they can save on their initial investments on the tracker system and the electrical system, including the fewer connectors, the fewer cables needed, and so on. Besides, the civil work related can be saved too. Further, the Vertex N product is going to save more on the logistics. Take the 210R 595 watt module as an example. With the same quantity of modules in a container, the total power is increased by about 5.3% compared with the ordinary ones, which not only leads to the saving on the transportation fees, but also help to reduce the effort for the customer clearance and the logistic management. Then how comes the second question is how Vertex N product is able to generate more electricity compared with the PERC ones. The first is the lower temperature coefficient. In the actual application, the working temperature of cells are usually higher than 25 centigrade, which is the IEC standard, and that causes the power decrease of the module. Take the 595 watts module as an example. By applying the NG19RC.20, one of the Vertex N product family, it is able to have 4 watts higher power compared with the P-types when the cell temperature is at 45 centigrade. And therefore, the power loss can be reduced by 0.8%. Besides, the Vertex N product is able to generate more electricity due to the lower degradation, with the 1% as the first year degradation and the 0.4% annual degradation. At the year 30, the Vertex N product is able to generate about 2.5% more electricity compared with ordinary PERC types, which creates more value and ensures higher payback for the customer. Last but not least, the Vertex N product is able to generate more electricity because it has the higher bifaciality compared with the PERC modules, which is about 10%. Therefore, the customers can benefit on the extra power gain from the real side of the PV module. Of course, it depends on the albedo condition. For example, the Vertex N product, which generates all those 3 advantages, is able to generate about 3.34% more electricity compared with the PERC ones on the grassland. And the advantage is increased to 5.42% when albedo is higher. Last but not least, here comes the ultimate question is whether Vertex N products reliable enough to maintain such an excellent performance during its life cycle. Regarding the LID degradation, theoretically speaking, the Vertex N products will have the better performance compared with the PERC ones because it is lack of boron oxygen pairs. And according to the tests, all the 4 pieces of Vertex N products showed a degradation less than 0.5%. As a comparison, the average degradation of PERC ones are about 1%, highlighting such kind of advantage. Regarding the LETID, to some extent, the hydrogen is believed to be the main cause. And with the optimized hydrogen preservation technology, the hydrogen TOPCon cells are carefully controlled and lead to the better post-LETID performance. As you can see on the table, all the 3 pieces of Vertex N products showed a quite nice performance after 4 times of 162 hours degradation. And some of the results are even positive. As a comparison, the PERC ones showed a much higher degradation after only 300 hours of exposure. Besides, the Vertex N product its all-sided agent resistance is proved by passing the enhanced test sequence, which consists of the TC600, the H2000, PID 192, and the integrated mechanical stress testing. Compared with the IEC standard, which allows 5% degradation after 1 time of the standard test sequence. All the Vertex N modules show the much better degradation after the double or even triple of the standard test sequence. Last but not least, the largest member, NG21C.20, has successfully passed the enhanced hail test, which has a diameter of 35 millimeters. And with a 2 millimeter dual glass structure, this module is able to have a power change less than 0.5% after the crash of such kind of large hails, extending its application scenarios across the world. Except for the lab tests, The Vertex N product is proved to have the trustworthy endurance based on a field test since the year of 2016. And that is located in Menghe, China, where all the modules are put above the water. And inspiringly, after the 6 years of field exposure, all the 10 pieces of N-type samples showed an average degradation less than 1%. Besides, their extra power gain was observed from 2.93% to about 3.79%. And that figure can be expected to be higher if the albedo is higher, like on the sand ground or on the ordinary grounds. Then finally, here is the latest progress of Trinasolar's industrialization of Vertex N. Till the end of this quarter, we are going to have the module production capacity higher than 10 gigawatts. And this figure will be more than 30 gigawatts till the end of this year. Okay, that's all from my side. Thanks for listening.
Impressive expansion plans, Jerry. That looks good. So a few questions, maybe. I think let's maybe stick a little bit to the 210R cells. So there was one question. Can you just explain once again the dimensions of the cell for those, and what's the difference again and the idea behind that? Because I think that's important because it's still new.
Yeah, and for the standard one, the 210R cells has a dimension of 210 multiple 182 millimeters. Yeah. So okay. It's as you can see, it's a regular one, right?
Mm-hmm. And for which products are you using this cell?
We named our product family by adding word R to the product name, like the D09R, DG19RC.20, and also the Vertex N product family. Both the small sized 440 watts module and the middle sized 605 watts module are adopting it. Yeah.
Okay. Okay. Then maybe let's talk. You talk about N-type. It's an N-type TOPCon cell. So how's your view on heterojunction and also IBC?
Yeah, that's quite a good question. And please let me share some of our understandings. And so first of all, since the year of 2023 and in the next 2 years, we believe that the N-type TOPCon is going to dominate the whole industry because as you can see before, we have made quite much efforts in the industrialization, and now the whole supply chain, the ecosystem is mature enough, and we are able to produce more than 10 gigawatts of modules. While for the N-type HJT, there are still key challenges before the perfect industrialization, which are the cost problem, or in other words, the materials needed. And for the IBC application, as some of our friends showed before, it has a limited application scenario because its bifaciality is actually lower, so not really suitable for the utility projects and for some big CNI projects that the modules can generate power from its backside. Yeah, so we believe in the next 2 years, the N-type TOPCon will be the dominator, and after that, the N-type HJT can get a nice share if overcoming some key challenges. And for the IBC application, it will be a more pay more attention to the niche markets or some small segments.
Okay, okay. Just understood. I think you also showed some test reports. Where are these accessible somewhere?
Yeah, exactly. Actually, we are preparing a big package to include all the data sheets, the test reports, and the value assessments based in the PVCs. Also, our field exposure test reports, and make it into a package for our customers' reference. And I will share it later with you.
Okay, super. I think that would be nice. There are also a few more questions in the chat. If you have time, it would be nice if you could answer whatever you can. And then we continue with the next presentation. Once again, Jerry, thanks a lot for this.
Okay,
Nice
thanks a lot.